Using the CMMI cloud computing and big data infrastructure as a foundation, predictive analytic models could focus on a variety of dimensions that comprise the contextual and outcome regime needed to more fully understand the empirical evidence associated with CMMI adoption and usage. The CMMI Big Data database would be populated with globally oriented outcome-focused information spanning the range of CMMI assessment and results data, software project assessment data beyond the CMMI, global software competitiveness data, software inspections data, and known cybersecurity weaknesses. With the emergence of global software development as a business model to produce software products rapidly enough to dominate their niches in a globally competitive workplace, there is a need to obtain the deepest possible understanding of global software competitiveness and the leading indicators that permit systematic reasoning about it. An enterprise wishing to advance its global software competitiveness needs a framework to organize these leading indicators and a mechanism to assess its readiness to compete. While the framework rewards those who effectively compete with others, it reserves extreme rewards for those who dominate their niche. Mere competition is distinguished from competitiveness. The vision for achieving global software competitiveness is presented as a strategic plan composed of direction-setting themes, objectives whose achievement locks in the gains, and leading indicators whose assessment guides improvement. The most bedrock attribute of competitiveness is the sustainability of workers' wages. The Council on Competitiveness further states that it is the ability of U.S. products and services to meet the test of international markets while sustaining or boosting the wages of the workers who produce them. Stages of competitiveness are organized around the activities associated with supplier control, customer control, competitor control, and event threat control. Supplier control is achieved by establishing an attractive workplace culture, achieving maturity in process and skills, deepening industry relationships, and retaining personnel. The art of customer control is achieved by deepening customer relationships, balancing business factors, and achieving total customer satisfaction. Controlling the competition is achieved by deepening community relationships, fielding superior products, and setting the direction for the niche. Controlling event threats and change is achieved by guarding against government intrusion, applying strategic software management, performing due diligence, and understanding reality. Issues surrounding competitiveness include increasing dependence on software to achieve competitiveness is not being met with increasing domestic workforce capability and capacity. Enterprises in search of value continue to choose offshore outsourcing for skills and cheap labor. Cybersecurity shortfall threatens continued loss of intellectual capital. Government tax policy, misguided regulations, and antitrust litigation offer impediments and uncertainty. The austerity and affordability challenge has the effect of tying our hands just when the starter's gun signals the start of the race. Just what are the leading indicators of global software competitiveness? Here are the 83 leading indicators associated with global software competitiveness. Let me touch on a few that may be on your mind. Boldness in decisive action in the face of uncertainty. Chaos, where disruptive technologies threaten to alter the landscape at any time. Civility, demanded by the diversity of the global village. Commodity view, with its low margins and low status. Disintermediation, and skill sets less stratified by level or seniority. Intellectual property, like patents, trademarks, and trade secrets. Network security, and exposure in a dangerous world. offshore outsourcing with its risks and rewards and partners in faraway places. Open source because it's there for you and your competitors. Privacy, both internal and external. Piracy of intellectual property. Staff churn and loss of experience, knowledge, and corporate culture. Time to market and frequency of release. The Global Software Competitiveness Dependency Network, shown here, suggests the difficulty in locking in gains and the need to achieve maturity at each level, and in fact at each node. An essential resource in this effort is a complete CMMI assessment history of every CMMI assessment ever done anywhere, and the analytics and models that connect the CMMI and its process areas with leading indicators of business outcomes. The Capability Maturity Model Integration, CMMI, is being adopted worldwide by government, military, and commercial organizations as the standard for process improvement. The CMMI is a framework of best practices that focus on assuring product quality through process performance. Now that the CMMI has been organized into 3 constellations for assuring an organization's capability to perform development, acquisition, and service, there is a need to extend the range of value of the CMMI to a new normal. The value of the CMMI to an organization varies depending on the domain of forces to which it must respond, such as reputation, economics, mission, competitiveness, outsourcing, and high assurance. The penultimate value of the CMMI is the degree to which its ability to deliver satisfactory responses in a strategic context is demonstrated when faced with these competing forces. It is time to revisit why organizations should adopt the CMMI and to refresh the value proposition. While the traditional treatment of the value of the CMMI in terms of cost, schedule, productivity, quality, and customer satisfaction, and return on investment is sufficient to promote adoption of the CMMI and even to sustain a process improvement initiative through the early maturity levels. The value of the CMMI determined in this way is likely to be underestimated as the organization approaches higher maturity levels. As an organization improves its process maturity, strategic imperatives need to replace waste and neglect as the driver of CMMI value. Only those organizations able to elevate their game and transition from tactical to strategic use of the CMMI will be able to reap its full value. The value of the CMMI to an organization is different depending on the domain of forces to which it must respond. Where a valued aspect is dominant, such as reputation and image, economics and finance, mission and continuity of operations, indicators of competitiveness, supply chain management and outsourcing, and trustworthiness and high assurance, an optimum response may result, thereby simplifying the making of commitments, setting goals, and conducting trade-offs. In less optimal situations, a blend of valued but competing aspects may lead to a more diverse response to these forces. An organization driven by reputation and avoiding the risk of loss of trust may place a high value on trustworthiness and security, along with the steps needed to assure these attributes. The telecommunications, financial services, and medical sectors, where trust is all important, fit the reputation scenario. An organization driven by economics may place a high value on profitability and attributes like cost control, productivity, and span of responsibility. The financial services, manufacturing, and utilities and energy sectors fit the economics scenario. An organization driven by mission may place a high value on sustainability, capability control, and capacity control, as well as reliability, availability, security, and resiliency. The telecommunications, transportation, medical, and defense sectors fit the mission scenario. An organization driven by competitiveness may place a high value on release frequency, time to market, and innovation, as well as cost and schedule control and predictability control. The manufacturing and e-commerce sectors fit the competitiveness scenario. An organization driven by outsourcing may place a high value on release frequency, time to market, and innovation, as well as quality control, configuration management, and span of responsibility of onshore staff. The manufacturing sector fits the outsourcing scenario. An organization driven by high assurance may place a high value on trustworthiness, including quality control, defect-free, predictability control, resiliency, and frequency of release. The telecommunications, financial services, transportation, medical, and defense sectors fit the high assurance scenario. CMMI process areas by cultural drivers and leading measured outcomes are shown here. The association of CMMI process areas with leading measured outcomes helps to pinpoint the cultural drivers that deliver the elements of value for a business sector. Senior executives interested in obtaining a snapshot of software projects within the organization can utilize the Project Suite Assessment Benchmark. This will reveal findings that may suggest immediate action and suggest areas of organizational neglect of software assurance. The Project Suite Assessment Benchmark is composed of an enterprise background questionnaire to establish enterprise context and a software project assessment to calibrate and benchmark individual project status. These software project assessment steps will highlight numerous opportunities to reveal the process, management, and engineering gaps that feed the accumulation of technical debt. Each of these steps will be discussed in turn. For best results, the software project assessment is revisited periodically throughout the project. The fifth step is to understand when requirements are fully known. That is, at inception, now, later, or at completion. Also, who is responsible for identifying the requirements, and how stable are the requirements over time? An artifact that assists schedule management is the milestone completion schedule, which shows the planned or replanned completion month for each major milestone. The y-axis indicates the planned date, and the x-axis indicates the calendar date. This chart provides a clear record of what did you know and when did you know it. More importantly, the graph reveals the degree of schedule stability and perhaps the source of instability. The eighth step utilizes budgeted completion, current actuals, estimated completion. A useful byproduct of this information shows the distribution of the percent of cost variance by account and the range of overrun frequency and underrun frequency. The 14th step is to indicate whether software quality assurance is in place and functioning. At the very least, quality assurance should reveal the frequency distribution by defect type along with any actions taken to close the gap. Certainly, unattended defects are a source of technical debt. More importantly, the distribution of defect types may suggest gaps in software product engineering and the practice of disciplined software engineering. Here's my contact information. I would be happy to receive questions and have discussions with people on this important subject.